embed improvement, maybe through prompt engineering by giving right context or examples or few shots and chain of thought or zero shots. So you can implement all those into the system as well. Then the main continuous improvement lifecycle that I want to look at is the loop engineering. So loop engineering follow the pattern observe. So where the agent observe what it has in the system, it observe the feedback, the success and the error, then it diagnose. So it diagnose what causes success and what causes failure, and then it improve on the failure. It uses the success to it uses the success, right, and then improve on the failure by studying what went wrong and then or improving that next time, and then next time it works, those failure will not be repeated. And the testing, it also tests against the failure whether or whether the proposed correction is acceptable, and then you deploy, and then the agent learn from that process. So feedback pipeline. Feedback pipeline collect data from systems, from system interaction and convert it into actionable insight for improvement. So feedback pipeline is just like data engineering pipeline that collect information from the system, process the information, separate it into success and failure, and then apply the successes and then learn from the failure, and or continue in that process until it's able to learn and perform with the best of its ability. So feedback pipeline consists of data combination where data are ingested from various metrics defined through the observability, and failure identification. It identifies the failure and successes, and then main function, it detects recurring errors and the cause of the errors and cluster similar problem, analyze root cause and suggest improvements. And then it uses example tools like DSpy, Microsoft Trace, automatic prompt optimization, DPU, Grafana, and Loki, etc. So this is how feedback pipeline works. So we have automated feedback analysis. Automated pipeline analyze agent activity to identify problems early. So, and the pattern detection, it detects failure and prompt misinterpretation, and also increase latency. Then behavioral drift, it detects drifts in the system as a result of the misbehavior or failure and successes. And then it implement common techniques which are statistical anomaly detection, log clustering, pattern recognition across workflow, and then it scale advantage. So this technique allows system to identify problem early at a scale human cannot monitor. So root cause analysis. Once failure are detected, system perform root cause analysis to understand why they occurred. Remember, the feedback contains success information and failure information. So once the feedback is fed into the system and it detects failure through anomaly, then the next thing is to perform root cause analysis and detect why those problems actually occur. And the step in root cause analysis are workflow tracking, where the agent reconstruct the chain of decision and action to visualize the failure path. We have fault localization, which identify the exact components responsible, such as specific prompt to or reasoning step. And we have pattern recognition, where the agent determine pattern of success and failure, or whether the issue is an isolated incident or recurring systemic problem. Then it also has the fifth pattern, which is impact assessment, where the agent evaluates the severity and business impact of the identified failure. And then after following this pattern workflow or localization, pattern recognition, and impact assessment, the next thing is to apply strategic fixes by implementing strategic solution, fixing the underlying system weakness rather than addressing superficial symptoms. Then another way of improving agentic system is using human in the loop review. So human in the loop is very, very important when you are implementing high risk, when you are giving high-risk decision to agent. So automated system can handle every cases, necessitating human oversight for complex high-risk scenario. So we have ambiguous intent, or these are conditions where you need human in the loop. So when you have ambiguous intent, human clarify user intent when the automated system lack confidence, when you have high-risk decisions. So these are critical scenarios and ethical dilemmas requiring human judgment. You have complex edge cases where handling unique situations that do not fix existing automated pattern being implemented. We have reviewer provides, where human reviewers include engineers, product managers, data scientists, and US experts, because these are the people that design the system, so they should be included in the review process. Then escalation criteria. So cases move to human when confidence is low, error persists, analysis is inconclusive. So when you build a feedback pipeline and the feedback has been fed into the system and the system can still not correct the error, then human escalation is needed as well. So the next improvement design is prompt and tool refinement. So once issues are identified, system can be improved by refining the core instruction and capability of the agent. So this can be done by prompts. So this is the process of improving instruction by clarifying language, adding examples, or breaking tasks into the steps. We have contextual updates, which is providing additional context to help the model reason more effectively. We have tools where the agent or where you enhance agent by fixing parameter, handling, adding new capabilities as well, and improving tool chaining. And then we have error handling, which is where you improve how tools manage and report unexpected results. And then we have optimization methods. Tools like GSpy, Microsoft Trees can automatically optimize prompts and tool usage by using training examples. So the next design of improvement is aggregating and prioritizing. So feedback system generates many potential fixes requiring structure. So those potential fixes are frequency, where you prioritize based on how often an issue occur across the system. We have severity, where you evaluate how harmful the issue is to user experience or to the entire operations. We have feasibility, where you determine effort and resources needed to implement a fix. We have strategic importance, where you align improvement with overall product goal and roadmap. We have a risk of recurrence, where you assess if the issue will continue damaging the system if ignored. We have an improvement backlog, where you create a structured actionable backlog for engineering team to follow. So these are ways of aggregating and prioritizing our feedback system or design in loop engineering. Then we have experimentation and shadow. So before deploying improvement, team must test them safely to measure real-world impact and reduce risk. So ways of experimenting are experimentation goals. So measure impact, detect regression, and deployment and reduce deployment risk. So you can also use shadow deployment, where a new system runs in parallel with a production system receiving the same input. You can use passive logging, where outputs are logged for analysis but are not shown to users. And then you can also implement safety, where discovery of edge cases in real world conditions without risking user experience are implemented. So another way of improving agentic system design is through A/B testing, where where you compare what you have produced with what you are expected to produce or what the users are expecting. So A/B testing ensures statistically reliable comparison between current and proposed system. And ways of implementing A/B testing are split testing, where users are divided into version A control and version B new version. You can also implement task success rate, where you compare how effectively each version completes user objective. You can implement response quality, where you evaluate the accuracy and relevance of agent output. You can also use user satisfaction, where you measure direct user feedback and interaction metric. You can use statistical reliability method, where you ensure that observed improvement are significant and not due to chance. So another way of improving agentic system design is through Bayesian bandits. So Bayesian bandit is an advanced experimentation method that dynamically adjusts traffic toward better performing variant over time. And ways of designing for the Bayesian bandit is by implementing what we call the dynamic traffic shifting. So traffic moves towards success version during the experiment rather than staying in fixed split. We also have faster optimization. So this reduces the time required to identify the superior system configuration. We have efficient testing, where you maximize performance for users even while experimentation is still active. We have continuous learning, where you use useful this is useful in dynamic environment with many possible configurations. So these are ways of implementing Bayesian bandit: dynamic traffic shifting, faster optimization, efficient testing, continuous learning. Then we also have continuous learning, which is just like reinforcement learning and in-context learning. So agents adapt behavior within a single session by modifying prompts based on immediate feedback. And how do they do this? First one is in-session adaptation, where agents modify prompts to adjust listening steps or incorporate user correction instantly. So when you give example in the prompt or you apply correction, the agent adopt it instantly into the session and then begin to operate it. Then prompt augmentation. So we have said that you can we can add specific examples directly into the prompt to guide behavior, and then you can use instant adaptation, where behavior changes immediately without requiring a full model update. You can also implement personalized responses, where you tailor agent action to the specific context of the current user. And then we have the general limitation to this is that changes are temporary and disappear once the session ends. Then another way of improving agent is offline retraining. So offline retraining update model or prompt using collected production data to create permanent improvement. So way of doing this are data collection, where the agent collect production data and curate them to high quality data sets. Labeling and curation: data is prepared for fine-tuning or prompt optimization. Model updates: prompt are updated or model are fine-tuned to reflect learned improvement. We have validation and deployment, where changes are validated offline, and deploy through control experiment. And then we have long-term alignment, where you provide permanent large-scale updates and better long-term system alignment. Then key takeaway in this lesson: so AI system improve through continuous feedback loop that detect, test, and embed improvement. So what is raining now is has moved from harness engineering, where you design things like adapter or like ambassador around the agent and to improve the agent. That shift to loop engineering, where you design feedback for continuous learning, recursive learning, and to better the performance of the agentic system. So what we have discussed in this lesson are feedback pipeline, which is critical for detecting issue and generating actionable insight from system interaction. We've also discussed experimentation, which is essential for safely testing improvement via shadow deployment and A/B testing. And we have discussed various types of A/B testing that you can implement. We have discussed continuous learning, which is the mechanism for embedding improvement permanently into the system so that the system no longer drifts. We have success factor, which is combining automation and human oversight, structured experimentation, and iterative learning all together into the system to achieve or optimal output. And then we have system evolution, or you can't design a perfect system from beginning, but you can always improve the system as it as it performs over time. So the ultimate goal is to build AI systems that continuously evolve and improve and adapt over time. So thank you for listening, and please do well to subscribe and like our channel. See you in the next video. Bye.